What's up, everyone? Welcome to another episode of Highline. Let me just set the scene for you and warm you up a little bit for today's conversation. Imagine you cross someone who is handy with technology. What they do is they go onto your Instagram, they take all of your photos and they split them up into hundreds of millions of different images, and they train a deep fake of you. They then find a video online of two people getting into it with their pants off, and they deep fake your face into one of the individuals in the original video. You get an anonymous message on your phone showing the first 3 seconds of that video. They threaten to send that to your significant other, or you have to pay $10,000. What would you do? Pretty tricky situation to be in. Well, welcome to the world of deep fakes. Today, we're going to be breaking down the deep fake detection market, a growing area of cybersecurity. A deep fake is synthetic media created using AI that looks real but is fake. AI has made it faster and cheaper to create synthetic media than ever before. Deepfakes are already having a large impact on society. They're changing the way we view courtroom evidence. They've been used to influence the stock market, spread misinformation, and introduce new forms of identity fraud. In today's episode, we're going to take a look at how deepfakes are made, how they're used for crime, why deepfake detection is hard. Take a look at some of the companies trying to create solutions to catch deepfakes. If you are a regular listener of Highline, so far we have learnt how to spot the ripple before the wave. We've had a look at how regulation creates new market dynamics. We know that what gets banished by the old gets reinvented by the young. We know how to lean into the unfamiliar because therein lies the opportunity. And what we are doing is we are building a nice composition of frameworks that help us identify and evaluate opportunities. We're learning to ask the right questions to see things clearer and more objectively. In today's episode, we are going to add another banger to our armory, which is recognize the seed, understand the tree, envision the forest, and foresee the harvest. This is going to help us understand what future problems are going to exist from a new technology. The reason why this applies to deepfakes is that if we had been able to use this approach when we noticed deepfakes becoming a more prominent thing on the internet, we would have had a better chance to foresee some of the challenges that this technology possessed. This would give us the opportunity to see what problems companies and governments are going to have as a result of this technology, and we can be very early in creating the solutions before anyone else recognized that this was the thing. That is ultimately how we want to position ourselves and what we focus a lot on the podcast. So today we're going to start off our conversation by sharing with you some famous deepfake stories if you are not aware of what deepfakes are. And I'm going to start off by sharing a story of a branch manager that was duped for $35 million. In early 2020, a branch manager of a Japanese bank in Hong Kong received a call from a man whose voice he recognized, the director of his parent business. The director had some good news. The company was about to make an acquisition, so he needed to authorize transfers to the tune of $35 million. A lawyer named Martin Zellner had been hired to coordinate the procedures, and the branch manager could see in his inbox emails from the director and Zellner confirming what money needed to move where. The manager, believing that everything appeared legitimate, began making the transfers and transferred $35 million to a random bank account. I mean, that is just fucking insane, right? And if you think about how sophisticated this crime is from a criminal perspective, they would have to figure out what the relationship is between the parent bank and the branch in Japan, figure out that this might not be an uncommon request, create a deepfake voice of the director, and then also create emails from a fake person and get that into the inbox of the branch manager, get it past all the cybersecurity and pull this off. And it shows us how sophisticated some of the criminals are that are utilizing this technology. And think about this, if you are new to a company and you get a call from your CEO who you might have only spoken to a couple of times, and it's your first couple of weeks at the company, and he asked you to go and send a whole bunch of money somewhere, it's going to be pretty hard to know the nuance in his voice if you haven't spent a lot of time with him. This is an example of how deepfakes can be used to deceive people that work at companies. And it's going to be an ongoing threat that companies are going to have to deal with. The other example that I want to talk about with you guys is the David Beckham deepfake, which shows a video of David Beckham explaining the benefits of getting the malaria vaccine. Now, the kicker is he speaks in 9 different languages, all with perfect pronunciation and lip syncing. And it's scarily real. And this shows us how deepfakes can be used to not only alter what people say, but do it with perfect pronunciation so that you could not actually tell whether he is a native speaker or he's not. And I urge you to go and look at it on YouTube. The other more concerning example is the deepfake example that happened in Ukraine in 2022. It was a video of Vladimir Zelensky, who is the president of Ukraine, asking his troops to lay down their arms in the face of the Russian invasion. This video wasn't really of a high quality, and you could easily tell that it wasn't real. But what it shows us is if they had trained a better version and they had been able to broadcast this on the national television networks, imagine the geopolitical consequences of a video like this and how much of an impact that could have had. The other deepfake example worth mentioning is the plane crash at the Pentagon. In May of 2023, someone created a plane crash at the Pentagon. It was obviously fake, but a number of major news houses reported on this, and that actually caused a stock market decline. So the question we should be asking ourselves now is, what are the implications for video and audio communication writ large? And there's another example of how deepfakes have been affecting the integrity of courtroom evidence. There was a case of a mother who accused the father of verbal child abuse of their daughter via the phone. What she did is she submitted a phone call as evidence. The father claimed that it wasn't real. With an audio investigation, they found that the mother had used free software and tutorials to add in the abusive language in the audio file. This evidence was obviously acquitted, but what does that say about all video and audio files in courtrooms moving forward? It's a harrowing example of the implications of deepfake in the courtroom, where there are significant consequences on the line. If we take the examples above, what do we know? Well, we know that this technology can be repurposed for malicious intent. It can be used to steal money, misinform citizens, deceive and persuade people. Because of this, and because of how the technology can be repurposed, we know that deepfakes are going to provide a clear threat to companies and governments. This is likely a problem that they're going to care about. Furthermore, if you watch the David Beckham deepfake, it's scarily real. And what's important to note about this is it wasn't created using CGI. CGI is the technology that is used to create synthetic media. The movie Avatar, which I'm sure you're familiar with, is entirely created using CGI. The problem with CGI is it's extremely expensive. It costs $570,000 per minute to run, which is nuts. So here, right, we have this new tech, which is machine learning, that has been access to a lot of data, and it's now being repurposed to create this synthetic media, which is arguably of a better quality. This is like flashing lights that we need to be paying attention, because there's obviously been a technical leap here that did not come from the original technology to create synthetic media. First of all, we need to recognize that yes, this was created using a new technique, but we need to go and understand, why have they been able to create such high quality content? What has happened? What has changed that has been able to create this new form of media? And that's where we need to go and understand how deepfakes are made. So deepfakes are made primarily using two ways. The first is generative adversarial networks and auto encoding. And at the heart of this, machine learning is the key ingredient to make deepfakes cheaper and faster than ever before. To create a deepfake of someone, you need to train a neural network on many hours of real footage of the person to give it a realistic understanding of what he or she looks like under different lighting and under different angles. So if we take generative adversarial networks, or GANs, the way that we can think about this is it has two computational functions. First is generation and discrimination. And in the generation phase, I want us to think about an art forger. The art forger wants to create the perfect copy of the Mona Lisa and sell it on the market for hundreds of millions of dollars. Then we have the detective, who is the discriminator. And the discriminator's job is to view the market and make sure that there are no fake copies of the Mona Lisa sold. So what happens is the generator, the art forger, starts to create the perfect copy of the Mona Lisa. And at the start, he's really bad at creating these copies, and he submits that to the detective or the discriminator, and he points out all the reasons why this is not real. And what happens is the art forger learns from that feedback, he makes changes, and he iterates, and he does this millions and millions of times until he gets so good that the detective can no longer tell whether this deepfake is real or whether it is fake. And at that point, the neural network has been trained. The second method is the auto-encoding approach. This also has two main approaches, which is encoding and decoding. Encoding takes an image and it passes it through the neural network. It then splits the image up into many different pieces and it finds the most important features of that data. It then passes through the neural network again, simplifying and compressing the data more and more. Then we have the decoding phase, and the network attempts to reverse the process. It goes through a series of network layers, and each layer aims to recreate the original data step by step from the encoded form. By the end of the decoding process, you should have data that accurately matches the input data. And you can no longer tell the difference because the network has figured out how to create the perfect deepfake. The thing is, neural networks are not a new concept. They've been around for a long time. What has changed though is the access to a lot of images, and that has been made possible by the internet and social media. The more data there is online, the higher the quality of the deepfakes that you can create. The other thing that has changed is in 2010, if you wanted to create a deepfake, you would have to go and buy a warehouse full of computers to do the computation. And that would have been very expensive, not only from a capex perspective, but the electricity to pay for all those computers would have been astoundingly expensive. The cloud provides the infrastructure to do this cheaply and have access to the most cutting edge microchips to perform the computation. It's the combination of the data given by the internet, the neural networks, which is the technological advancement, and then the computational infrastructure and advanced chips that has made it cheaper and easier to create deepfakes than ever before. Now we can recognize the technical leap to figure out how they were able to create this new form of media, which is arguably better quality than CGI at a much cheaper cost. And these are some of the reasons why. We've got to peel back the layer and understand these different factors. The next question we should be asking ourselves is, what other information do we need in order to understand the opportunity in this market? I think we should be asking ourselves is, how fast are deepfakes growing online? Is the prominence of deepfakes growing? And I've gone and found out some information to give us an indication of the growth of deepfakes. And in 2019, there was 15 million deepfakes on the internet. In 2020, that was 29 million. In 2021, that number grew to 44 million. In 2022, that number grew to 58 million. And in 2023, that number grew to 106 million. So it's clear that we are seeing an exponential growth of deepfakes on the internet. Now, this begs us to the question is, how are we going to identify the deepfakes to stop the impact of these misinforming individuals, stealing money, and really just being used to confuse everybody? So that brings us to deepfake detection. And deepfake detection is about creating software to recognize a deepfake. There are three main ways to deal with deepfakes at the moment. The first is media authentication, which is like putting a stamp on videos and photos. If the stamp is still there, then the video hasn't been changed. Then we also have media provenance, which helps us show where the original video came from. Think of it like checking where your shirt was made. One way to do this is by seeing where else the media has shown up online before, and then it's likely that it's going to be a deepfake. And then lastly, we have deepfake detection, which is the software piece. The problem though is deepfake detection is very hard. And the reason why it's hard is because most of the machine learning algorithms that you use to train a deepfake come from open source data sets. And if you're not sure what open source means, it essentially means you can have access to the most cutting edge machine learning models for free. The benefit of open source is it creates transparency, collaboration, and innovation, and provides widespread access to individuals to create new types of technology. The other side of open source software is that hackers and malicious deepfake creators also have access to the same resources. They can study them, understand how the detection works, and then refine their deepfakes to evade detection. This is one of the key reasons why deepfake detection at the moment is very, very difficult, because everyone has access to the same data. Most people agree that catching deepfakes online is okay for now, but in the future, as that number exponentially grows to maybe 400 million in the next 2 years, the best way to deal with them is either going to be through software detection or authentication. The problem though is the best models are not very accurate. Current models are about 65% accurate at picking whether it's a deepfake or not. Think about that. That means 35% of deepfakes go undetected and people can't tell the difference, which is scary. And it shows us, though, the opportunity in this market to create new forms of technology because the current ways of dealing with this problem are not that advanced. The deepfake creators still have an edge, and this makes us understand the magnification of the impact to businesses and governments. The next area we need to be asking ourselves is there money flowing towards solving this problem? And the answer is an astounding yes. Global cybersecurity spending in 2023 will reach 219 billion and grow to nearly 300 billion in 2026. Investments in cybersecurity hardware, software, and services will jump 12% from 2022. The biggest security spenders this year include banks, manufacturing companies, professional services, and federal governments. These four industries will account for more than 1/3 of all cybersecurity spending this year. Not only does this show us where the real major market is for deepfake detection by indicating the companies which spend a lot of money, it also shows us that they are actively spending money in this area to keep up with the advancements to this new technology. And the reason why is clear. It costs them a lot of money. Cybercrime is predicted to cost the world $10.5 trillion annually by 2025, up from $3 trillion a decade ago and $6 trillion in 2021. In order to keep up with the advancements in this new tech, they're going to have to keep spending money, which just shows us the wealth of opportunities available in this market. Let's now explore some of the companies operating in the deepfake detection market that are going to try and capture some of this demand. The first company that we have is Intel. Intel created a deepfake detection tool called FakeCatcher. FakeCatcher can view up to 72 videos at a time. FakeCatcher works by looking at how the color in your face changes to see how blood moves across your face. That's pretty wacky technology. It's called PPG. I'm not going to pronounce the name. I'll save you the laugh for next time. FakeCatcher checks to see if the color looks natural as they would when your heart is pumping blood. It's really hard to replicate this in a deepfake video. In a test of its accuracy, it was right 91% of the time, making it one of the best deepfake detection tools for spotting videos. Intel plans to use its Salesforce connections to roll this out across the industry. The most interesting company in the market is a company called Reality Defender. What a name for a product. Reality Defender is built using an assemblance approach, which in the context of AI and machine learning refers to a technique where multiple models or algorithms are used together to make a decision or prediction rather than just relying on one single model. Think of it as getting a third, second, or fourth opinion all at once to make an informed decision. Using the assemblance approach, it combines multiple models to improve accuracy and the robustness in detecting deepfakes. This method captures a broader range of patterns, reduces individual model errors, prevents over-reliance on specific data patterns, and overall offers better performance under challenging conditions. Reality Defender's model accuracy hasn't been publicly announced. However, what they did say is that they can capture extremely high accuracy only viewing a very small part of a video or audio file, which is kind of the game changer in Reality Defender's product, is being able to only watch a quick snippet and then be able to tell whether it is fake or real. Currently, their system is being deployed at a number of very large organizations, including finance, media, and government, and it is proven effective in detecting deepfake content in customer calls, social media images, political propaganda, and misinformation. So I'm going to be keeping a close eye on Reality Defender for us on the podcast. The core insight into the deepfake detection market is, how do we spot this early? I've been thinking about this. If we had used the approach that we have taken today on the podcast by meticulously going through and understanding the different examples, what their implications are, how the technology works, why it's a better and faster, cheaper approach, how that has been enabled. If we had looked at it from that structural point of view in 2017, I think we might have been able to predict that deepfake detection was going to be massive. And by that time, if we had created a company, we would have been in perfect positioning. The maxim that we can use to describe this activity is recognize the seed, understand the tree, envision the forest, and foresee the harvest. The framework that we can use to apply this maxim is the FutureSight Framework, and it has the following headings: spot the game changers, get to the basics, think scale, see the big picture, predict the path ahead. If you want a copy of this, I'll put it in my newsletter. Spot the game changers. The game changer is the clear leap in quality of the deepfakes created. It indicates that there is a technological advancement that we need to go and understand. It also did not come from CGI. If we get to the basics, we need to understand why and how this occurred. We know that the basics of the deepfake technology is machine learning. We know that it has gotten cheaper due to access to cutting edge machine learning models, access to computing power at scale from the cloud providers, and access to cutting edge chips for training. The combination of these factors has made it cheaper and easier to create deepfakes than ever before, and also improve their quality. If we think about the scale, we know that the infrastructure around cloud and data allows us to create a large quantity of deepfakes. They are also distributed on the internet, and there are a number of providers which have billions of users. We have evidence that there is a growing number of deepfakes online, and we can understand that there is a scalable nature to deepfakes. If we see the big picture, we know that they can be used for malicious intent and that governments and companies are going to need to protect themselves. We can also assume that there might be a new way to create entertainment. If we predict the path ahead, it's so obvious that deepfake detection is going to be an enormous market and a hard problem for governments to solve. And this is the framework that we should have been thinking about when we first saw this. But I know it's really hard. But hopefully, with our practice on the podcast and you and me, as we learn together, we will get better at being able to predict these things. To summarize, we were looking for a technical leap from a core innovation. We need to ask ourselves, can it scale? And if it can scale, then we know it's going to be a big thing. And then we need to start positioning ourselves. What we want to do is we want to research it, understand the technology, predict the path ahead, do the work to trust our own judgment. And then we've just got to fucking go for it. Build the product and expect the market to come to you. At least we'll be early. And if it fails, oh well. As we come to a close on the podcast, I want to share with you some of my ideas for this market and deepfakes in general. The first is creating a deepfake technology to create videos of me. I was able to just record the podcast via an audio format, and then it automatically created a deepfake video of me presenting the podcast. I would use that. It would save me a lot of time and it would save me a lot of effort. And that's one idea that you could positively use deepfakes for content creation. The other role for deepfakes is entertainment. We can assume that a lot of movies moving forward are going to be made using machine learning. You could also use this to recreate actors from the past. If there is an older demographic where they had a very famous actor who has since passed away, you could recreate that individual and put them in a new movie, and that might be able to attract a new type of audience that wasn't previously possible. The other idea I have is historical recreations. Imagine being able to speak to Abraham Lincoln or watch the Martin Luther King speech in real life, all possible with deepfake tech. The last is education and training. Imagine at school, you could actually have a conversation with the individuals that created the theories that you learned. There are many positive applications of the deepfake technology, and I expect to see a convergence between virtual reality and the machine learning technology on the deepfake side to create these virtual worlds. All right, guys, that is all for today's episode. This was my first podcast recording using video. If you like this podcast, please could you subscribe to my YouTube channel? I'd appreciate the support. Expect to see a few more clips coming out about our podcast topics. We've covered a lot today. It's clear that deepfakes are going to be a major problem, but I think that this market was a good training ground for us to be able to see the problems and opportunity that arise from a new technology. I'd love to hear from you guys about the frameworks that we have discussed on the podcast today. If they are valuable to you guys, if you think we could put them to use, please let me know. That is all for today's episode. The next episode is going to be on GLP-1s, which are the drugs called Ozempic and Wegovy. Stay tuned for that one. That is another interesting market that we'll take a look at. See you guys.